Hello.
Hello.
Yeah, good evening.
Hi, how are you?
Good. Not that good, but still okay. Still, I'm in office.
Oh, okay.
For last 2 days, as I told, like last Saturday, I went home at 10, and yesterday
Oh,
was at Ruiz, and today, actually, I left early, but in between, I had to come back.
oh. No, you're still in office. Then how, when you will
Yes,
reach
yes.
your home?
I have no idea. I guess by 10 or something.
No, I think you are taking lots of risk. You as a, yeah, it's difficult, right? Anyway, as a job, you need to that's why.
Uh, yeah, the thing is, we have some urgent works, and we are running out of resources.
Hmm. Okay,
So
no
I
problem.
cannot
Anyway, take
deny
care.
them.
Take care. Okay.
Yeah, okay.
Yeah. So you
Yeah, but
practiced
the thing is,
everything?
I practiced. I was not able. I just did the things, but I was not able to practice with the plan which you provided. I didn't get time, so I will do it shortly.
Okay, no issue. I think if you are like not okay means like we can continue later also because you might be stressed
Um,
in the work itself.
no, it's fine. Like, can we have like half an hour or something? Is that fine?
Yeah. Then we
Then
can
I
have
we
class.
can
Don't
have.
worry.
Okay, okay.
So you have the start pro and everything, no? So that
Mm-hmm. Now?
no, I'm asking like, is that
Oh,
okay?
yes,
Like
yes, yes.
you are
Okay.
watching in smartphone or a laptop?
Smartphone. It's fine. I can see.
Okay, no problem. Yeah.
Okay.
So you can see my screen, right?
Yes, yes, I can see.
Yeah. So we didn't see like concrete design, right? Concrete design we seen already. No.
Yeah. No, no. We just saw the beams,
Ah,
columns, then
okay.
plates, such thing.
Okay.
Yeah.
No, I think we seen concrete design, right? No.
We just started, I guess. We just told like how to do that,
The
how to
concrete
select
design.
and all. Yes, concrete design, only that.
Okay. I think which one we selected? We did 1 minute. So this is what is. Okay, this is what we completed, right?
Yes, like
Concrete design.
footings.
Yeah.
Yeah, concrete designs and footings and all we discussed.
Uh, okay, so concrete design we done already, right? So that what we can do is like,
Okay, so concrete is in the sense like footings, such things.
no, after analysis successful, like you're supposed to go to design, and then here you can just select
Mm-hmm.
which design you want, concrete or steel design,
Oh yeah, okay, okay, yeah.
and you can just select parameter, define parameter, and put, and we can see the analysis, and then you can see the takeoff options.
Errors. Yes, yes, we did
Yeah.
this. Actually, I didn't reach this portion yet.
Okay. See here.
That's the thing.
So not only the errors and warning, this concrete design is
Mm-hmm.
important, na? So this one we discussed, remember?
Yeah, we changed. Yes, yes.
Yeah. And then
One
so
by
you
one.
can just go for takeoff. See, you can see here this how much the concrete quantity and also the bar sizes and also the weights and all. This is what
Okay.
concrete design. So this you can do, na? Like once you are doing, then you will be knowing how to do it.
Yeah, I hope so. Yeah.
Okay. Okay. Anyway, like I will just go for a fresh file so that I will
Mm-hmm.
tell you like seismic load and wind load today. Okay.
Okay.
So for seismic load, like I will start creating some structure. Okay. You can also use the run structure wizard. Anyway, now we already
Okay.
came into it so that we can able to just do by ourselves. Um, Okay, only this portion I will consider. So the translational repeat. So here, so in the y direction. So I can just put some 8 floor and then 3 meter link steps and then click OK. Okay, so then we can just go to translational repeat and then Z and then so some 5 meter. Okay, we can just have link steps and open base. So this is what the big structure. So this is like a
Mm-hmm.
symmetrical, not unsymmetrical structure. Like in this span, it
Yeah.
is very less, and then here we have more span. Okay,
Okay.
but rectangular kind of building. So like this, you can able to
Mm-hmm.
model whatever you want, and then now you can just go to general and then support and then create, and we can also add always add the fixed support for the structures. Okay,
Okay.
then you can assign to the selected nodes, so you can ensure that. Okay, now after that, like we can just go here property and then define. So you can just go for different property. Otherwise, like I will just go for a 0.45, 0.45. Okay, because this is a big building.
Mm-hmm.
Okay, or even you can go for even more also because okay, assign to view both beam and column
Okay.
same sizes.
Okay.
So you can see in the 3D view how the building looks like. Okay, the frame
Okay.
structure. Okay. Now it is simple. This is normal. Always we supposed to do the same. Now you can go
Supposed
for
to. Yeah.
infill plates.
What one? In
Infill plates, right? To fill the in between
fill the
space.
okay. Okay. In fill place. Yeah.
Then we can just go for thickness and also like this. And so now what we can do means like we need to go for loads and definition. So now we are going to
Okay.
discuss something in the definition part. So for seismic analysis, it is always necessary to start with the seismic definition before creating any loads. Otherwise, you will get error. You can't
Okay.
able to get the result. So we need to start
Mm.
from seismic definition and add. And here you can able to go for different code books, different regional codes.
Okay.
Okay, so UBC codes, Japanese codes, and even Indian standards. You might be aware of IS 1893.
Yes. Yes. I was familiar.
Okay, so that we can able
Okay.
to go for. So, so I will just start with the Indian code. Then I will also go
Okay.
for some UBC codes like that. Okay.
Okay.
See here for this UBC 1985, we are having a parameter like this. For this one, we are
Mm-hmm.
having a parameter like this. So everything you
Mm.
can able to input your own values actually.
Okay.
Okay. So here these things you can refer the inputs that you got from or from the reports that you are getting from, or you can just collect these reports from your regional, local area, local bodies like that. Okay.
Mm.
Or here like I will just go here and you can see these values automatically like populated, but here you can also go for
Okay.
generate in IS 1893 and you can see here only for India, right? You can select the city you want, otherwise you can just
Mm.
select the zone, and based on the zone you can able to put the value. See all these things now you can able to refer the particular code book. So maybe first or second page you will
Okay.
be having a map and you can able to see the colors and also zones. So all this value you
Yes.
can
Yes.
refer the code book. So no need to buy hat. So nothing. If you want
Okay.
to know what is this, so you need to refer the IS 193 code book and you need to
Yeah. I
just
have did
go.
for wind loads actually.
Yeah,
Wind load, not
yeah, yeah.
seismic, but wind load. I remember.
Okay. So like that, you need to refer. So all this value we can able to just it will automatically come actually. See here it is like a
Okay.
special RC moment resisting frame. Even we can also go for
Mm.
ordinary RC moment resisting frame like that. So different load bearing masonry wall. So what about your structure? So what kind of
Mm.
structure? Then accordingly you can just choose all these things. Okay.
Okay.
So you can just have ductile shear walls in the sense like you might be having lift, like all around the lift, like you will be having some walls. These walls are called shear walls.
Mm.
So like that,
Yeah.
different you can able to just select, and also like here steel frame if you want steel frame with
Mm-hmm.
eccentric braces. Now bracings. So in
Yes. Yes.
the vertical members, it is connected with the bracing means. So it is even more strengthening the structure.
Strength. Mm.
Yeah. So accordingly, you can
Strengthening
just
component actually.
select.
Yeah. Okay.
Yeah. So accordingly, the values it will be automatically changed so that you can able to put your
Mhm.
own. But I think here you can't put. Here it will automatically come, but here you can able to put your own value.
Okay.
So the soil types also you can select, and also damping ratio you can put, and also steel frame or RC frame structure or all other building. And here
Mhm.
importance factor also we are having. But in your in the latest version you might be having another also one, and also important in this is 1.5, because important buildings are all like hospitals, universities, even the workplaces. Because lots of people every day they used to come and sit and work there, right? This is an important building. But if it is like
Yes. Okay.
but if it is like a residential building, like only very few people will be staying there. So then they will
Mhm.
consider only one general building. Even there is another
Okay.
factor 1.2 also, that 1893 might be. Maybe in this version it is not updated. Okay.
Okay.
So accordingly you can select all these things. So generate. So accordingly you will get the value,
Mhm.
or you can put your own thing. So only you need to add it,
Okay.
nothing else. Once you add, then sulfate factor it will ask. So one, okay, sulfate of one.
Okay.
And now here you can go for joint loads if you want member loads. In member load, concentrated and also uniform distributed. If it is a brick load, uniform, or somewhere in the beam, then concentrated load. Or even you can just
Mhm.
go for slab weights, the pressure. So the reference load I will tell you
Okay.
later. We discussed diaphragm and center of rigidity. No, right?
No, no, we didn't discuss.
Okay, maybe reference load we can discuss later. So that don't worry
Okay.
about anything. Now for the seismic analysis, I will consider only the floor weights.
Okay.
Because if you're considering floor weights, everything it is going to act in the column and also to the obvious to the ground. So I'm just taking
Mhm.
so just 3.5, because it is a pressure. Now you should not put a minus. Okay.
Okay.
So whenever pressure it is coming, don't put minus, and only the this one Y range you need to put.
Only why? Oh, okay. Yeah. Yes, only why. Ah.
No,
Oh, yeah.
what?
Seismic low direction. Yes, why?
Yeah,
Okay.
yeah.
Okay.
Okay, this one it is what it is. Mm. So this is like in the Y it is 27 maximum. So 27, and then X you can just put a 8, and then Z you can just put 25, and you can
Okay.
see the
So
one way
how we are
distribution.
measuring the dimensions? Like,
From here, display node
yeah.
distance.
Okay.
And you can also just remove that from here, these two.
Sorry. Okay. Okay.
Uh, and you can also just go for dimension for all the display. It will show all the display like this, but this is not useful.
Mm-hmm.
You can remove it, but only this thing it is useful.
Okay.
Yeah. So through this, like we can able to find the maximum value. Anyway, minimum is 0 comma 0 comma 0, because I was not changing anything. 0 comma 0 comma 0. If you changed anything, then
Mm-hmm.
you need to put the minimum also. For example, you might be having a minimum 10, so then you need to click. So for that, what you can do is just to select and just double click it. So this we discussed already.
No, we didn't.
No, na. So like this,
No,
we can
no,
just
no.
double click and you can see the coordinates also. So double click here. This is maximum. So here diagonally opposite. This is minimum, and then this
Mm-hmm.
is a maximum. So 27,
Uh,
825.
can you explain it again? Like,
This one node cursor.
mm-hmm.
Select and then just double click it,
Okay.
and then double click here.
Mm-hmm.
And this is maximum. That is minimum.
Okay.
Hmm. Okay. Once you've done everything, and the one-way distribution, you know, right?
Yeah.
uh, the length by the length divided by width, if it is like less than 2 or more than 2, then it is like a two-way slab and one-way slab.
Two
Okay.
ways left. Okay.
And then I'm just going to add it. So okay, once you add everything, perfect, the definition part is done. Now you can go for load case detail and add. Now you can just go for seismic, and I will just go for EQ in X direction, earthquake in X direction, earthquake in Z
Okay.
direction, because in the floor both direction we will be getting the effect, right? Earthquake.
Yeah.
So is that you're supposed to select do seismic and then you need to put EQZ. Okay. So here you can able to add the seismic load. Now you can just go
Yes.
to seismic load and you can see X direction. The factor is 1. Okay, and you need to add it. So it will automatically assign. And you can able to see that later. I will show you. Now I will just go
Mm.
here again and seismic load in the Z direction and then 1 and then add. Okay, and then okay, okay. So there is something scale, right?
Yeah.
In the here you can also see the label load values. Okay, okay. This after the result you can able to see the load acting in it. Okay, because I also selected the load value so that you can able to see the
Mm.
values also. Okay.
Okay.
Okay. So what you need to do is analysis and print. Now you need to go for add. Okay. Now you can just go something here. If I want to go for center of gravity, if you want to see the center of gravity of the building, you can just go to
Mm-hmm.
STAAD editor and then just you can just type before finish. So just enter the finish. Now you can just go for print CG. So print CG in the sense it is going to print the center of gravity in the report. Okay.
Okay.
Otherwise, what you can do means like here you can also go. So from here, right, post processing.
Where? I didn't see that.
No.
Post.
After analysis, like you are just going
Mm-hmm.
in the perform analysis.
Okay.
All we are putting. Apart from that, you can also go to post print, and here
Mm-hmm.
like you are going to have a see post print here the define commands it will come
Where?
here.
Okay. Okay.
So define commands and here like you have a CG and you can able to add it. So you can see twice the time it is coming. Actually, sometimes if it is not coming from here, better you need to go
Mm-hmm.
to the STAAD editor and you can use because see now we have two CG.
Okay.
Okay, we will
The same
see.
one, right?
Same
Ah,
only
okay.
so that you can delete, right click and delete command.
Delete. Yeah. Okay.
Okay, now we can analyze it. This is going to print the center of gravity.
Okay.
Okay, so we are getting 0 error, 2 warning. So it is perfect. So we can see what's the warning actually. Okay, since it is like
Mm-hmm.
a one-way, two-way warning, and also this one, it will be always coming for the seismic. Okay, now we can
Okay.
see the result. Okay, center of gravity is coming. So this is the center of gravity of the particular building, and the total self weight of the building is 7,600.563 kilonewton. Okay,
Okay.
this is because of the print CG command. Now, what we can do, seismic analysis in the sense, time period and base shear. So we are going to discuss something about time period and base shear. Okay.
Okay.
So here you can able to see the time period. So time period, this 0.88 triple 835 second, and also SA
Mm-hmm.
by G values and the base shear. So these things you can able to see, and this is what like normally we are analyzing for seismic analysis. For all code books, you will be having time period and base year. Okay, maybe the symbol it will be varying. Okay,
Mm.
so this is what the seismic analysis. So we done correct. That's why like we are getting this results. Okay,
Okay.
so now what we can do means like there is something loads and definition. Like now you can see. So this here, can you able to see that one, how the earthquake loads are acting?
Yeah, it's
And you can
acting.
see, and
Mm-hmm.
then you can see how the it is acting in this way also.
Okay. Just I should take loads and definitions, right?
Loads and definition.
Okay.
This is we already assigned, but this is like we can able to see after the analysis.
See, okay.
So, but the scale here, like you can just go for label and you can switch off the load value. Normally by default, it will be like that. If you want to see the load value,
Okay.
you can just go and see that also.
Okay.
Okay. So now we can just go to post processing and you can just select the
Yes.
thing. And as usual, reactions. And for the beam, you can able to see the shear forces and
Mm-hmm.
bending moment. And also the axial forces. So you can able
Okay.
to see everything as usual deflections. Okay, and you can also see the stresses and animation. So you can see animation since it is like earthquake analysis. So you can able to see how the building. I think the load is very negligible for the big structure.
Oh, okay. It's not active.
You can able to see how it is acting. Okay. Mm. For the X, we can see also. I think in the post processing, and you're supposed to see like this, and the displacement right here. Correct. See,
Oh, okay.
see the
Okay.
displacement, correct only.
Okay.
See, for
I
this,
see the
the earthquake acting, the building going to sway like this, and for the
feel like this.
EQZ, so you can
Mm-hmm.
just change the direction. So just to change the direction, see, you can see this
Mm-hmm.
is how the earthquake, correct only, and you can see all the values here.
Okay.
Okay. So here the values, and you can just see whatever the thing. See here for beam also, you can able to see everything. Okay. But
Okay.
animation is not coming. So you can just reduce the or increase the frames. So if I'm just increase the frame, 50 frames. So deflection you can apply. See, now you can able to see.
Oh, okay.
So you need to just put the frame numbers more.
Mm-hmm.
Because before the result I was not satisfied because I was thinking might be wrong, but this is not wrong. This
Okay.
is correct only.
Good. Okay. Okay.
So only to increase the frame better.
Hmm.
Okay. So you can change the direction so that you can see how the building
Okay.
going to. Okay. Okay.
Yes.
So
Okay.
this is simple as that. Okay. Now this is what it is like. So what we can do is like if you want some other code. So what we can do is like go to loads and definition.
Mm-hmm.
So I will just delete everything. For example,
Mm-hmm.
this one I will delete. This one I will delete.
Okay.
So this one also I will delete. So again I will go for seismic definition. So
Okay.
I will go for a UBC 1994. So this value, na, if you want, you can put, but actually these values
Okay.
we will get after the analysis. So these values you can
Okay.
modify and you can add it. Once you add, right, a self-weight factor, same it is coming. So everything normal, the same only you need to put. So I was putting 3.5 kilonewton as conservative calculation. You can calculate accordingly as per your loading conditions. Okay.
Hmm.
So this one 27 8 25. 27 8 and 25. So as usual the same, only I just to change the code, regional code. So
Hmm.
now you can need to put the EQX So actually no need to delete also, but sometimes it will show error. That's why better to delete and redo again.
Okay.
So add it. So as usual, seismic load and the x direction 1 factor, and then z direction 1 factor. So now you can just go for analysis. See here you can see UBC load coming because before IS 189.3 it is coming. Accordingly, it will come. Nothing. See the results and all the same warnings. Now you can just see the control F, but now you can't able to search a time period. So you can just scroll and you can see. See, once you're scrolling, right, you can see here. This is similar to the Indian code. So here the C value and also the TATB values, and you can see the base shear 626.42 kilonewton and all we are getting, right.
Okay. Yeah. So it's just the difference of codes, right?
Two different codes. Yeah.
Okay.
X direction and also the other direction. Yeah. See, you can able to see the difference. Yeah, then it's correct only. See, I was thinking the same value coming because of the applied loads and also the member. Okay, but here you can able to see the TB value. Here it is different, and here it is
Mm.
different. So because we are just not putting a symmetrical structure. If symmetrical structure, everything it will be similar only.
Okay.
So that's why. Anyway, that's why I put unsymmetrical structure, and you can able to see the values and all. That's it. Once you get this one, base shear is important for seismic analysis. So this is what
Mm.
like here we can able to see the things, and now you can just go to post processing and you can able to work with. So as usual, this thing.
Okay. Oh, now we can see the sway.
Yeah. So you can just hold control and then you can just scroll down. Okay.
Okay.
For this EQX, the same, but we can see the different code and you can also compare the values also like that. You can able to study for. Okay.
Okay.
Yeah. So now after this, like we can able to go for the wind load. Okay.
Can we go with the wind load like tomorrow?
Ah,
Is that
okay,
fine?
better. So you can practice the
Yeah.
seismic load now.
Practice this one. Yeah.
Hmm.
Okay. I think that will be better. Like if it's too much, I cannot
Otherwise,
get
yeah,
into
yeah,
the
yeah.
head
You
today.
already in stress, right?
Yes. Yes.
Okay, okay.
Exactly.
So when you will practice, like you are not going to the home soon
Uh,
now. Now the time, how much the time? There might be 8:30, right?
yes. Yes. The
Uh,
thing is, I'm even thinking about taking one leave, like 1 day leave, so that I can invest some time in software.
yeah, yeah.
I even thought like that. Even Saturday, Sunday was like, I was too busy this
Oh,
weekend.
okay,
So I even thought like I can take leave for 1 day. I can
okay.
practice. Then only I can focus it properly.
Yeah, yeah, yeah. You need to take care of yourself also, right? Yeah.
Yeah, and the thing is, I need to finish this job and I have to shift to other.
Oh,
All
shit.
these things should happen. Yeah, like I told you now, currently I'm working in a HSA company. So by January, I have to shift to an engineering company.
Oh,
So
okay.
that's why I'm doing this course urgently.
Oh, okay, okay. Yeah,
So
yeah. You told me well in the beginning. Yeah.
yeah, all these things should happen within this 2 weeks.
Okay, okay. Yeah.
So I have
Okay,
to
then.
invest time for this and also studies.
Yeah, yeah.
Okay.
So, okay. Take care. Bye.
Yeah.
Practice, na.
Yeah.
Don't
Thank you.
forget.
Bye. No, no, never. I will do it
Yeah,
for sure. Yeah.
yeah.
Okay.
Okay.
Okay. Bye.